Right. So I've gone ahead and made this revision sheet for you all, including all the summary details of every experiment and a checklist for revision. Yeah. So the first thing I want to go over is that fact that there are 8 core practicals, and each of them you should fit into a structure called that I like to call CRIMPS. So that stands for, now, if you look at the headings of this table, you can see that first one stands for calculations that you must do prior to drawing a graph. Yeah, prior to drawing a graph. So, and second column in CRIMPS, R means repeat or an average. So you should think about whether the random error is significant in any of the measurements, and if so, you can repeat and average that reading to reduce the effect of random error. Then I stands for instruments. So you should know what instruments are used for each measurement. Yeah. M stands for mathematical model, what you use for drawing the graph. So you will notice that a lot of these are connected to the theory, but you need to modify this equation depending on what you are taking as your y and x. And in each experiment, I have given some sample x and y and gradient and intercept values. Those are standard. Y is dependent variable, x is independent variable, m is gradient, and c is the y-intercept. And lastly, we have the precautions. This is quite important because in each experiment, there are some errors that you may encounter. If you're using a ruler, there are some standard errors, zero error, parallax error, verticalness error, which occur anywhere you use a ruler. So I've referred to them as, like, for example, here parallax error and zero error occur due to the ruler. So I haven't repeated them in this row. I've said to refer to the first experiment. So together, these CRIMPS, calculations, repetition, instruments, model, precaution. The S is for safety. I didn't bother with it because you can write that. So CRIMP, when you memorize that, I find that the whole experiment cohesively sticks in your brain. So the correct way to study this would be to take some kind of reference material, which is either your practical books that you use at school, or the official Pearson lab book, or physics and maths tutor short notes, which I will show now. Go to physicsandmathstutor.com, go to physics revision. In international A levels, next unit 3, and here you have all the experiments, and you will notice that now what I have summarized there, if you are not so familiar with that experiment, you need to go through the full version and yeah, read it through. It's very short, 2 pages, I think 2 or 3 pages at most per experiment. And that covers the method, the calculations, safety. And under notes, these are the precautions. This is where physics and maths tutor people put the precautions. I have only noticed errors in one sheet, which is the the dual beam oscilloscope experiment. This note that's there in physics and maths tutor is wrong. Unfortunately, speed of sound in air experiment, don't refer to this. Instead, in this document, I have included a video link. There's a British teacher that demonstrates this and explains the theory behind it. Right. Now that that's done, oh yeah, let me give some context. In the old syllabus, there used to be big essay questions, 1 or 2 big essay questions of 10 marks. Now in the new syllabus, it has been replaced with structured questions, but the content that is being examined is the same. The difference is that they have broken it into smaller question pieces. So when you are doing those, questions, the examiner is asking you about a particular core practical or something similar to the core practical, you should think, what is this guy asking me? Is he asking me the calculation, the repetition, and so on. You can go through those key points and see what this fellow is asking, right? Additionally to this, you need to know how to read a micrometer screw gauge and how to read a vernier caliper. Now, how can you confirm whether your knowledge is correct? Just search on Google, micrometer screw gauge simulation. There's some guy on GitHub has it here. I found that this is kind of good. Amrita one is also kind of good. But there are a couple of options. So you can just run this. Let's see, I don't think it. Oh, here. I think you can click create problem. You can. Let's check it out. Oh, yeah. They'll give you an object and then yeah, you can create problems here, but I don't think the solution is there. However, it's a good tool to practice with. If you're unsure of how to do this, use micrometer screw gauge and vernier caliper. I'm sure there is a short YouTube video that you can find. If not, send me a text. Right. So vernier caliper also similarly, you can search and find a simulation to practice your skill. And if you don't have the skill, may check a short 5-minute YouTube video. If not, text me. Right. Now, definitions wise, you should refer to the document I've made called the Ultimate Unit 6 study document. If you don't have it, text me. But in that, the key points that you should look at is the definition of uncertainty, random error, systematic error, accuracy, and precision. You will find these on page 2, page 3 from a glossary. So there are a lot of words here that you can learn, but mainly you need to know the correct meaning of accuracy and precision so that you don't just use them randomly. They have specific meanings. Precision means how close the repeat values are to each other. Accuracy is how close the measured value is to the true value. That is completely different. Don't interchange them. And you should also know accuracy is affected by random and systematic errors. Precision is only affected by random error. You should know the definition of a random error and a systematic error. I have put them in the last page, I believe. Have I? Yeah, it's not great. But systematic error is an error that affects all readings equally. Example, 0 error. Then a random error is an error that affects each reading in a random way. Sometimes it's too big, sometimes it's too small. It's due to inherent randomness in the thing that you're measuring. So, for example, if you're measuring air temperature, the randomness comes from air currents. If you are measuring the time to go down a slope, the randomness comes from the random arrangement of rocks on the slope. Or if you're doing it on a lab level, it's a random arrangement of the roughness of that plane. Right. Now, back to the thing. You should know these definitions so that your mind works properly. You should definitely know what is uncertainty, and in fact, you should know how to calculate uncertainty for a single reading using uncertainty equals half resolution. For that, you will need what is on the first page of the study document. These are the common instruments, their resolutions and their uncertainty. You will find that the uncertainty is always half of the resolution, right? Yeah, except now there are some small exceptions like this star here, because when you're using a ruler, normally you take 2 measurements, right? Each measurement is uncertain by half a millimeter. So when you take 2 measurements, that those two add together and give a total uncertainty of 1 millimeter. Another important thing is in digital instruments, even though there are a lot of numbers, there may be a lot of numbers, but those numbers are fluctuating, not settling. Then we don't take those numbers. So when you are taking the resolution, you should take the smallest decimal point, which is not fluctuating. That's your resolution. That's the smallest. By the way, you should know the definition of resolution also. I think I will add that here. Resolution is the smallest change that the instrument can measure. So, see, in an electrical instrument, if those smaller decimal points are fluctuating, that means the instrument can't really measure it. So, you should take the smallest decimal point that is stable. And for uncertainty, you should take the decimal place and divide it by 2, the normal mathematics way. For multiple readings, you will find the notes for how to calculate uncertainty on page 4, but it's very detailed. Okay. Now, if you want the summary, you go to my other document. If you want the detail and solved examples, you come back to this one. So here there's some data. Of course, if there's anomalous data, you must discard it before doing this whole procedure, right? For repeat values, you use half the range to calculate uncertainty. You should also know how to calculate percentage uncertainty. You take that uncertainty and divide by the measured value, which you are doing for a single reading. For repeat readings, percentage uncertainties, what have we discussed? The half range. Excuse me. Yeah. For multiple readings, we use uncertainties half range. Now for percentage uncertainty, I will add that actually. Percentage uncertainty. Yeah, never mind. I will add it in the document itself. Half range divided by mean. And for this one, percentage uncertainty. Okay. Then significant figures, you must make sure, you must do a couple of papers and make sure that you are giving your final answers of any calculation to the same number of significant figures as the lowest number of significant figures in the data. The example of this is given in the ultimate Unit 6 study document. Hold on, I think it's in the second page. Yeah, this example. So we are taking some value of pressure, but the force is given to 4 significant figures, area is given to 2 significant figures, but the answer must be to the lowest one. So when this 2 significant figures is lower than 4, so we give final answer to 2 significant figures that you should know. Then graphs, you need to plot a couple of graphs. If you're unsure, you send it to me to check. But you need to score well in the graph question because it's free marks and often students get stuck there because they don't have the practice. The exam is not the time to practice. You should practice and go big so that a lot of the skill is filled in with your muscle memory. Right. Now, to end with, let me send you to Gorilla Physics. Gorilla Physics is one good channel if you are not recalling any experiment. Yeah, Bex Masters, he has changed the thing. If you go to his playlist, you will find there should be something about, oh yeah, there's one full like, yeah, there we go. All the A-level core practical experiments, this is the UK A-level ones, all of them in one video. It's only 1.5 hours. Yeah, but it includes the year 13 A2 experiments as well. So you don't need that. So half the video. Or if you want another alternative, there's another website called A-level Physics Online. I think that's the name of the channel. Yeah, Physics Online. Those guys are great as well. quite high quality. Especially Core Practical 2, I liked their Core Practical 2 better. You'll find it in playlists probably. All the Core Practicals are there. Nice. Practical experiments. Search and see, like search the name of the experiment. Then you will find a video from this guy. That was very high quality. Right. Best of luck and text me if you have any issue.